So in this lecture, let's discuss other types of equations. So let's start with a exponential equation or a rational equation. So equations that have rational exponents. So let's take an example. Let's say I have x power 5 by 4 equals 32. So how would you solve this equation? So the easier way to solve this is to multiply power on both sides. So put power on both sides, the reciprocal of the power on x. So the original power is 5 by 4, so the reciprocal becomes 4 over 5. So put that power on both sides, it becomes x power 5 over 4 over 4 by 5 is equal to 32 whole power 4 over 5. So x becomes x power 5 by 4 times 4 by 5 is equal to 32 to the power 4 by 5. So 4 4 gone, 5 5 gone. So x becomes 32 whole to the power of 4 by 5. So we can write 32 as 2 power 5. So 2 power 5 times 4 by 5. So 5 5 gone, we get 2 power 4. So x here is 2 power 4, so which can also be written as 16. So this is how you can solve an exponential equation. So let me give you another one as an example. So let's say we have x power 3 by 2 equals 125. So notice that here we are putting on both sides. So 3 by 2 is the original one. So you are multiplying 2 by 3 on both sides. So you are putting the power 2 by 3 on both sides. So it becomes x power 3 by 2 whole to the power 2 by 3 equals 125 whole to the power 2 by 3. So it becomes x power 3 by 2 times 2 by 3. So 3 3 gone, 2 2 gone equals 125 to the power 2 by 3. So x becomes equal to 125 can also be written as 5 cube whole to the power 2 by 3 can be written as 5 power 3 times 2 by 3. So 3 3 gone, you get 5 square. So x becomes 25. So this is the value for x and how you can find the value of x. So let me give you another problem so that you can try it on your own. So try this problem. X plus 5 whole to the power of 3 over 2 becomes 8. Remember that the problem is the same, just the internal factor changes. So what you will do here, once you get the final answer for this equation, you will just put the 5 on the other side and get your final answer. So pause the video right here and try to solve this problem. So next let's discuss radical equations. So what are radical equations and how to solve them? So let's take a simple example of a radical equation. Let's say I have under root 3x plus 8 equals x. How would you solve this equation? So the first step is to square on both sides. So square on both sides. So that becomes under root 3x plus 8 square becomes equal to x square. So square and root get cancelled. You get 3x plus 8 equals x square. So you get x square minus 3x minus 8 equals 0. Notice that this is a quadratic equation. So the value is minus 8x square. So when you split it, you have to get minus 3x here. So the only way you can get minus 3x with minus 8. So minus 8 can be written as, you have 4 times negative 2. Negative, so for minus 4 times 2. You have 8 times negative 1. Negative 8 times 1. So in all of these choices you will never get negative 8x square. So what do you do now is use the quadratic equation. So using the quadratic equation we get a equal to 1, b equal to negative 3 and c equal to negative 8. So a equal to 1, b equals negative 3 and c equals negative 8. So x becomes equal to minus b plus or minus square root of b square minus 4ac by 2a. So x equal to minus of minus 3 plus or minus under root b square is minus 3 whole square minus 4 times 1 times negative 8 over 2 times a is 1. So you have 3 plus or minus under root 9 plus 4 times 8 is 32 over 2. So 3 plus or minus root 41 by 2. So x value is 3 plus under root 41 by 2 comma 3 minus root 41 by 2. So when you solve these equations, one thing mainly to remember is that x can never be, so x can be any value, so it does not need to be any single value. But remember that whenever you have the issue, you have to also remember that inside the equation you should never get, you can get imaginary numbers as well. So don't be alarmed if you get an imaginary number. So let's take a problem and let's try to solve. Let's take another one. Let's take a complex problem now. Let's say we have under root x plus 3 is equal to 3x minus 1. So again, square on both sides. So what happens when you square on both sides now? You get under root x plus 3 whole square equals 3x minus 1 square. So square and root gone, you get x plus 3 equals, so square root. So simplify this, you get a minus b whole square, you get a square minus 2 times a into b plus 1 square. So x plus 3 equals 9x square minus 6x plus 1. So to take these values onto that side, you get 9x square minus 6x plus 1 minus x minus 3 equals 0. So 9x square minus 7x minus 2 equals 0. So you have minus 18x square when you multiply the last and the first value, and you have to split it to get negative 7x. So negative 18 can be written as negative 9 times 2, 2 times negative 2 times 9. So the value is negative and the sum is also negative. So the only one you get is 9 minus 9x plus 2x. So substitute it here. You get 9x square minus 9x plus 2x minus 2 equals 0. So when you take 9x common, you get x minus 1 plus 2 common, you get x minus 1 equals 0. So 9x plus 2 times x minus 1 equals 0. So 9x plus 2 equals 0, x minus 1 equals 0. So x becomes equal to negative 2 by 9, x becomes equal to 1. Right, so this is how you can solve the problem. So these are the values for x that you end up with. So if the question says that x is a real number, then the value x can, so the x is a real number, then x can never be negative, because under root negative you cannot have real numbers. So that's why 1 will be the answer if you choose it to be negative answer only. Right, so make sure that remember that you can get both negative and positive values for x. So when you want to check it, you can try and substitute the values into the problem and check if the values work. So one way of checking them is, for example, when you put x equal to negative 1, what do you get in the question? So the question is root x plus 3 equals 3x minus 1. So let's put x equal to 1. So root 1 plus 3 equals 3 times 1 minus 1. So root 4 equals 3 minus 1. So 2 equals 2. So this is true. Let's try and put x equals negative 2 by 9. So what do you get? Negative 2 by 9 plus 3 equals 3 times negative 2 by 9 minus 1. So 3 ones, 3 threes. You have under root negative 2 plus 9 times 3 is 27 by 9, that equals minus 2 by 3 minus 1. So when you get minus 2 plus 27, however, what will be the answer? You get under root 25 by 9 equals, so minus 2 by 3 minus 1, so that becomes minus 5 by 3. So what you can do here is notice that root 25 by 9 can also be written as root 25 by root 9, which means that this is minus 5 by 3. Root 25 is 5, so it can be plus or minus 5 by plus or minus 9. so which means it should be minus 5 by 3. So notice that plus or minus can be the same, which means that you get only one answer, which is minus 5 by 3. So it also works. So the answer still works. So this is how you can judge an answer. So try another problem. Let's say this time you have under root 2x plus 3 plus root x minus 2 equals 4. So try this problem again. Do the same thing. Square on both sides until there is no root left. So until there is no root left, try to square the values on both sides and try to find the final answer. So pause the video right here and try to solve this problem. Next, let's take the next one, which is absolute value functions. So absolute value equations. So an absolute value equation looks somewhat like this. So mod 2x minus 6 equals 8. So if the equation is given like this, so if you see an equation mod a plus b equals k, then it can be written as a plus b can be k, or a plus b can also be negative k. So in this equation you can write it as 2x minus 6 is 8, or 2x minus 6 is negative 8. So these are both ways you can write the question. Now, depending on the absolute value equation, you can change the form into multiple forms depending on this value of k. So if you take the equation ax plus b equals k, then if k is less than 0, then mod ax plus b equals k has no solution. Right? It has no solution. If k equals 0, then mod ax plus b equals k has one solution. But if k is greater than 0, mod ax plus b equals k has two solutions. So remember this table so that you know which values are to be taken every time you solve the problem. So let's take an example. Let's say I have mod 6x plus 4 equals 8. So the first thing I want to do is check k value if it is either 0 or greater than 0 or less than 0. So here k is greater than 0, so it should have two solutions. That becomes 6x plus 4 is equal to 8 and 6x plus 4 equals negative 8. So 6x can be written as 8 minus 4. 6x becomes minus 8 minus 4. 6x becomes 4. 6x here becomes minus 12. X becomes 4 over 6. X becomes minus 12 by 6. 6 1 6 2's. So 2 2's, 2 3's. You get 2 by 3 and negative 2. So x here is negative 2 comma 2 by 3. But let's say if you have another equation that looks somewhat like this. So let's say we have 3x minus 5 minus 4 equals 6. So the first thing I want to do is put every constant on the other side except the modular value. So mod 3x minus 5 equals 6 plus 4, and minus 4 goes that side. So mod 3x minus 5 is 10. Now notice this value is greater than 0. So we can say that this does have a solution. So now we can write it as 3x minus 5 equals 10. 3x minus 5 equals negative 10. So 3x equals 15. 3x equals negative 10 plus 5. So x becomes 15 over 3. X becomes negative 5 over 3. So 3 1's 3 5's. So x becomes minus 5 by 3 comma 5. So this is the solution for the problem. So let me give you another set of problems. So try 3x plus 4 equals negative 9, mod minus 5x plus 10 equals 0, mod 1 minus 4x plus 8 equals 30. So try solving these problems. So pause the video right here and try to solve these problems. So next let's try other forms of equation. So one other one that you can do is, let's take a simple example. I can show you what form we can take it in. Let's take 3x power 4 minus 2x square minus 1 equals 0. Notice that this equation originally looks to the power 4, so but we cannot solve it. One way we can think of this problem is we can convert this into a quadratic equation. So for example, consider, so assume that here x square can be considered as u. Then 3 times x power 4 is x square whole square minus 2x square minus 1 equals 0. So in place of x square, if you put u, you get 3u square minus 2u minus 1 equals 0. Now you can convert this into a quadratic equation. Now you can solve it as a quadratic equation. So it becomes minus 3u square should be written in such a way where you get minus 2u. So you can write it as minus 3u plus u. So 3u square minus 3u plus u minus 1 equals 0. So 3u times u plus u minus 1 plus 1 times u minus 1 equals 0. So u minus 1 is out, so you get 3u plus 1. So u minus 1 equals 0, 3u plus 1 equals 0. So u equals 1, u equals negative 1 by 3. Now notice that we assume that x square is equal to u. So in place of u, put x square now. So x square is equal to 1, x square equal to negative 1 by 3. So put the value on the other side. So x square minus 1 equals 0, x square plus 1 by 3 equals 0. So x square minus 1 can be written as a square minus b square. So x plus 1 times x minus 1 equals 0. So x plus 1 equals 0, x minus 1 equals 0. X can be written as 1, x becomes negative 1. Next, here for the second one, notice it's a negative value. So x becomes under root negative 1 by 3, but this is going to be plus or minus. So x becomes equal to plus or minus. Now root negative, so negative 1 by 3 can be written as root negative 1 by root 3, which can also be written as plus or minus I by root 3. So it becomes plus I by root 3, comma minus I by root 3. So this is how you can think, you can see, you can find your answer. So try another problem that's similar to this. Let's say we have x power 4 minus 8x square minus 9 equals 0. So pause the video right here and try to solve this problem. So you can also try this quadratic equation for multiple complex problems as well. Let's say we have x minus 5 square minus 4 times x minus 5 minus 21 equals 0. Here we can assume x minus 5 as u and try to solve the problem. So use the assumption here and try to solve this problem. Let me give you another one that looks similar to this. Let's say x plus 2 square plus 11 times x plus 2 equals negative. So negative minus 12 equals 0. So again, in the second one, the assumption is that x plus 2 becomes equal to u. Remember that until you solve the problem, find u. At the end, in place of u, substitute x plus 2. So pause the video right here and try to solve these two problems.